Welcome to a code report solution video. In this video, we're going to be going over the solution to problem 2 from the topcoder SRM 734 contest entitled TheSquareCityDiv2. The problem states, John and Brew have found a nice horizontal plane and they built a square city somewhere on the plane. The city has n rows and n columns of houses. More precisely, John and Brew built a house at each lattice point xy such that x and y are between 0 and n. Winter is coming. Different houses have different heating systems and thus the temperature inside them are distinct. You are given the array T, which has n squared elements. The temperature inside the house at xy is T of x times n plus y degrees. Outside there is a lot of snow, and the only paths in the snow are along coordinate axes. Thus, moving from the house at x1, y1 to the house at x2, y2 takes the absolute value of x1 minus x2 plus y1 minus y2 minutes. Additionally, it's freezing outside, so a person can only stay outside for at most r consecutive minutes. Initially, there is exactly one person living in each house. Each person then repeats the following process. They find the warmest house they can reach in a single trip, i.e. within r minutes, and they move there. The people repeat the action until there is no warmer house within r minutes of travel from their current house. And the question asks us to find two values, A, which is equal to the number of houses that will contain at least one person once everyone stops moving, and B, which is equal to the maximal number of people who will share the same house. And we're supposed to return an array with exactly these two values, A and B. And note the constraints in this problem, n will be between 1 and 20, r will be between 1 and 40, and the values of the temperatures for each house will be between 1 and 1000, and as stated in the problem, each of these values is going to be distinct. So let's take a look at one of the examples that topcoder gave us and see what this problem is asking. So here is the input for one of the examples. We have our vector t, which represents the temperatures in each of the houses, and it's in a one-dimensional array, but we're going to represent this as 2 dimensions at the end of the day. And we have r, which is equal to the number of minutes you can travel outside. So a visual representation of this could look as follows. So note that the problem is actually stating that each of these houses and the temperatures in these houses is supposed to exist on the intersection of a horizontal and vertical axis. So the house should really be here, 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 and here, and then as following for the third column. But really we can just represent this as a 2D grid where instead of at the intersections where the house exists, we have each of the houses existing in one of these cells. And so what the question is asking is that we're going to have the people, and initially there's only one person in each house. Each minute or each turn, they're going to move to the warmest house they can. So for someone that is in house number 9, they're going to look at how far can I get in 1 minute. So in 1 minute, you can only move to a neighboring house. So the person in house 9 could only move here or here. But because these are both colder than the current temperature in this house, this individual isn't going to move anywhere. And the same will be the case for 6, 8, and 7. Because they don't have any adjacent houses they can move to that are warmer, they're all going to stay there. So we can represent, we know that 9 is going to stay in house 9 or the house at this location, and the same for 6, 7, and 8. And so for individual at this location for house 1, they have the ability to travel to house 9, the house with temperature 9, 3, and 6. Obviously 9 is the warmest, so 1's going to go there. We then look at individual in house 5. So they can go to the houses with temperature 7, 3, or 9. Obviously, they'll end up going here. And it's a little more interesting when we look at the individual in house 3. So this individual is going to end up moving twice. The first move will be to the house with a temperature 5. And then from there, they're going to end up going to house 9. So if we continue to do this, 2 and 4 are going to end up in the house with a temperature 8. And then this is where all the small numbers underneath these numbers are where individuals end up. So if we take a look at what this looks like in terms of the number of people in the houses, we've got 4 4 people in the top left corner, 1 in the top right and bottom left, and then 3 in the bottom right. So the question's asking us to return what's the number of houses that have at least 1 person, so that's 4, and what's the maximal number of people in a single that are sharing a single house, and that's also going to be 4. So that's what we'll return. So that's the idea of the question. So how would we go about solving this? So we're going to end up creating basically 3 structures. So the first one we're going to create is this grid. So we're going to transform this one-dimensional vector into a 2-dimensional vector, just so that it's easier for us to check, you know, to the left and right, up and down. And then the second grid we're going to create, we're going to call moves, and this is going to be a vector of pairs, which is just basically going to tell us for each element in our grid where would we move to. So for each of the ones in the top left and to the bottom and to the right of this element, these are all going to go to house 9, and you can see that the house with temperature 6 and 7 will just stay where they are. There's 3 elements going to house 8, and then the middle element, so the house originally with temperature 3, is going to move to house number 5. So each of the elements in this vector of pairs is going to store the coordinates for where this person would move. And from there, then we are going to be able to calculate where people end up by doing a recursive call. So for each of these elements, we're going to check, you know, where do we move to? And so if we're at this location, we'll check, okay, we need to move to the coordinates with the house with temperature 5, which is over here. And then we're going to go to the house with temperature 9. And then whenever we hit a house that has the same coordinates as its current location, we know we've hit a maximal sort of temperature and that we don't need to make any further moves. So we're going to have basically 3 functions to create these different vector of vectors, 2-dimensional sort of structures. And then once we have this final grid, we're just going to loop over it. We're going to keep track of how many non-zero values do we have, and then we're also going to keep track of the maximum and return it. And so this is a pretty inefficient algorithm. There are more efficient ways to solve this problem, but due to our constraints being so low, we know that R is going to be maximally be 40, and N, which is going to be the height and maximum height and width of our 2D vector, is going to be less than 20, that this algorithm will not time out. It will be efficient enough given the constraints of this problem. So let's take a look at our code. So here we're showing some macros and some type aliases at the top, just because we have a lot of loops in our code, and also it would be irritating to keep showing you guys a vector of pair of int. So note that vi is a vector of integers, vvi is just a vector of integers. So this is a 2D vector that has the integer as the type. A PII stands for a pair of integers, and VVP is a vector of pair of integers. So we can hide that now and just focus on our main function here. So this main function is returning a vector of integers that's going to contain the a and b. That's going to be returned from our find answer function. And then as parameters, we're taking an integer r, which is the number of minutes we can stay outside, and a vector of integers t, which represents the temperatures of the houses. So the first thing we're going to do is we have n member of our class outside that we're just setting to be equal to the square root of our vector t, and we're going to use this inside the following functions. And then we have 3 calls to 3 different functions. So A is our first grid, and we're calling initialize grid. So this is going to be the 2D representation of t, so we're passing t in here. Then we're going to calculate B, which is our grid that stores the moves. So this is going to be a vector of pair of integers, and so we're passing R, the number of minutes, and A, the grid that we just calculated, into this function. And then finally we'll be calculating C, which is going to be the final positions where each of the people end up. And then once we have C, we can just loop over each element and calculate the 2 numbers A and B that we need to. So let's take a look at our first function, initialize grid. So this is a pretty straightforward function. All we're doing is declaring our vector of integers, and then making use of the formula that was given in the problem to transform this one-dimensional vector t into a two-dimensional vector grid, and then just returning this. So note that we're not going to be doing a copy at this point. We're going to be using copy elision in order to avoid that. I'll leave a link in the description below if you're not too familiar with RVO or NRVO. So let's take a look at our next function. This is initialize move. So taking the grid that we just calculated, we're declaring a vector of pair of integers at the top here, and then we are calling the same nested for loop that we called before and setting each of these elements by just calling the simple find max function. So we're passing into it ij, the starting coordinates that we're sort of trying to find what's the element that we're going to move to, passing r and grid to it. So let's take a look at this find max function. So all we're doing here is we're keeping track of what the maximum temperature is that we have access to from our current starting point, which is given by xy, and then we have this pair of integers, which is going to be the coordinates of that maximal temperature. So we're basically doing a nested for loop once again, and we are just checking. We're doing some flooring and ceilinging here to make sure that we're not traveling further than we can go. And then we do this if statement just to make sure that we're not exceeding that. And at that point, we check, is the value in our grid greater than the maximum temperature that we found so far? If so, reset our maximum temperature, and then also reset the coordinates. And we'll complete this nested for loop, and then we'll have found the coordinates of the maximal temperatured house that we want to travel to, and we'll just return that. So once we've done that, we're going to pass that back and set our moves function. So that covers our first two functions, and then our third function is initialize final position. And so what we're going to be doing here, this is sort of similar to a quick union algorithm, but basically we're initializing a grid to store where everyone ends up. And then for each of our starting elements, we're setting them equal to these locals A and B. And then we're basically just checking, do the coordinates that are stored in our vector of pairs of integers at moves, are they equal to our current coordinates? And if they're not, then we basically want to take the coordinates that are stored in moves and then reset them to our new coordinates. So we're hopping from a certain element to another element, and then we're going to continue to do this check until we've found that we're sort of at a root, or what you'll call like a terminal element that you're no longer going to make any moves for. And so once we've finished this nested while loop, we are then going to do a post increment to that element of our 2D grid and then return that at the end. And so once this is done, then we have that final grid, and we just need to loop over it. So we're going to call and return our answer back to our main function find. So here we're just initializing x and y. This is the A and B that the question asks for. So x is the number of houses with at least one person in it, and y is the maximal number of people that are sharing one house. And so we're just once again doing a nested for loop, and we're checking if the number of people in the house are greater than 1, do a post increment on x, and we're constantly resetting y if y happens to be, or the number of people in our grid C happens to be bigger than our maximum. And at the end, we're just returning x and y using an initializer list. And the last thing to talk about is the time complexity. So the function that drives the time complexity is the find max function. So remember that this function was called inside a nested for loop that was over the length of n. So it's going to be n squared times the time complexity here. So it's a little bit complicated because we have a maximum function at the beginning and a minimum function at the end. So technically, if we're going to be really specific, we should incorporate these into our time complexity. But if we just sort of want to say what's the worst possible case, it's going to end up just being n and n again. So it'll be n squared squared, which is going to be big O of n to the power of 4.
As always, if you enjoyed this video and found it helpful, hit that like button. If you want to see more, make sure to hit that subscribe button. You can follow me on Twitter for reminders 30 minutes before contests start, and you can find all of the code shown in my videos on my GitHub page. Thanks for watching, and I'll see you in the next video.